This is 11.5 alternating series test. So now what we're going to look at series that kind of look like this. So something that has like a -1 to the n minus 1. So it doesn't necessarily have to be to the negative n minus 1. You can have -1 to the n, -1 to the n plus 1, something like that. And the whole point of this is that when you go ahead and expand things like this, you're going to have like -1, 1, -1, 1 patterns that, or maybe you might have 1, -1, 1, -1. So these are all different patterns in which you can see that the sign is changing. So if whenever you encounter a series that looks like that and you want to determine if it's going to converge or diverge, one of the things that you want to be able to do is maybe this alternating series test. And what this test says that if you have a series that's alternating, okay, notice here the signs are being different, and you have this b sub n term, okay, so something attached to it. And this b sub n satisfies these following two conditions. So A, it has to be a decreasing function, and then B, that b sub n, when you take the limit as n goes to infinity, it equals 0, then you can say that this whole series is going to be convergent. Okay, so it's very powerful. If you can show that these two are correct, you can show that this whole series is going to converge. Now, you might be wondering, why is that true? Well, let me just give you a little bit of a graphical sense of what this kind of looks like. So let's say you had the sum from n goes from 1 to infinity, -1 to the nth plus 1 power, I don't know, b sub n, something like that. Okay, so what exactly does this mean? Well, if I were to look at n equals 1 and I plug in n equals 1 in there, I'm going to have -1. Plug in 1 there, you're going to get squared b sub 1. So -1 squared is going to give me 1, so you're just going to get positive b1. So that means that my first sum, if I just were to add this first term, you're just going to get b1 because this is the only term that you're going to add. So if I were to look at it, well, here is b1. This is going to be my first term, okay, that I'm going to add. So the distance from 0, I add b1, I'm going to get my first sum. Okay, so that's just adding b1. Okay. Now, what about if I want to go ahead and add a second term? Okay, n equals 2. Well, when I put in n equals 2, you're going to have -1. Now this is going to be to the third power, b2. So now this is going to give me negative b2 because this guy is going to be a negative. Now notice b sub n is going to be decreasing, which means that b1, if b1 was 5, that means b2 cannot be anything greater than 5. It has to be 4 or 3 or 2 or 1 or whatever, okay? So this b sub n, b2 is going to be smaller, and what you're going to do now to find this new sum, you're going to add b1 plus b2, so you're going to get something that's smaller. Notice that I'm subtracting b2, something small, from something that's a little bigger. So my second sum, you're going to start from here. You're going to subtract b1, but it's not going to go all the way to 0 because we know that it's a little smaller than that. So this is going to be my new sum, my sum 2. This is what I got by subtracting b2 from b1, okay? Then I'm going to do the same thing. So n equals 3. You're going to have -1 to the fourth power, b3. So we're going to get a positive b3. Notice that this is decreasing, so when I add a b3 to this guy, it's not going to be the whole thing. It's going to be something a little smaller. That's going to be S3. That's going to be adding B3. So then you can kind of see this pattern that you're going to be now subtracting B4. Okay, so this is going to be my new sum. Then I'm going to be adding B5. So it's going to be my new sum. And so on and so forth. And you can see that this whole line is getting smaller and smaller and smaller and smaller until I reach to some particular sum. Okay, so I'm going to put reach is going to go to some particular number. Okay, so you can kind of see that if I can show that it's decreasing and that as n goes to infinity, all of this is just going to go down to a convergent sum. Okay. So that's basically the idea of the alternating series. So if you got that, that's great. If not, that's okay. You just need to know how to use this test. So let's go ahead and do an example. So So here's going to be my example. So determine if the series is convergent, or divergent. Okay, so that's what I want to figure out. So we have the sum from n goes from 1 to infinity of -1 n plus 1 divided by n. Okay, so now the first thing that you want to be able to do is notice that you do have a -1 term there, which means that this is going to be an alternating series. So one of the things that you might want to do is write it in the form of -1, which is this alternating thing, with its b sub n. So you're going to have the sum from n goes from 1 to infinity of -1 to the n plus 1, and then you have this 1 over n, which is basically your b sub n. Okay, now what we want to do is we want to use the alternating series test. So let's just write AST for alternating series. I don't want to write the whole thing out. So we need to prove two different things. We need to prove that b sub n is decreasing for all values of n, okay, and that that the limit as n goes to infinity of b sub n is equal to 0. Okay, usually the limit part is the easiest part. To prove that it's decreasing is probably, I think, the hardest part. To prove that it's decreasing, you can do many different things. One of the things that you can do is that you can show that 1 over n plus 1 is less than 1 over n. Or you can use the derivatives. And I'm going to go ahead and use the derivatives because I think it's a really good way to kind of refresh your memory on the derivatives part. So let's go ahead and show both of these things. So first you want to show that b sub n is decreasing. Okay, in this case, b sub n is equal to 1 over n. Okay, so now what I'm going to do is I'm going to take the derivative of this thing. Okay, so let's just say we had f of x is equal to 1 over x. So basically all I'm doing is I'm putting, instead of the n, I'm putting an x. So I'm writing it as some function. Okay, f of x equals 1 over x. So what I'm going to do, take the derivative of this, and what I'm going to get is -1 over x squared. Okay, just basic power rule. Okay, and all I'm going to do to show that something is decreasing, you're going to set the derivative equal to 0 and solve for the values of x. So remember, you have two different ways to do this. You set the derivative equal to 0 and solve, or you can also get your denominator equal to 0, because you can also have critical points on the denominator. Okay, so what you're going to get a -1 over x squared is equal to 0. Notice that if I move the x squared over, I get -1 is equal to 0. Okay, so this gives me nothing, so there's no critical points here. Then I'm going to set my denominator equal to 0, which in this case is going to be x squared equals 0, or -x squared equals 0. Okay, but that's all I'm going to get is x equals 0. Okay, now notice that at x equals 0, okay, if I were to relate it back to my sequences, it's just basically n equals 0. Okay, because remember, initially it was n. Now, n doesn't start at 0, it starts at 1, so this doesn't really matter. So does that mean that there's no critical points? Well, yes, there's no critical points, but we haven't learned anything. How do we know if something is decreasing? Well, if this first derivative is negative, then we know that the function is decreasing. So if you look here, the first derivative is equal to -1 over x squared. Okay, if I keep plugging any number that's greater than 1, okay, so if I plug in like x equals 3, okay, so that's going to give me -1 over 3 squared, that's going to give me -1 over 9. This guy is always going to be negative for all values of x or all values of n. So it doesn't matter what I plug into the derivative, I'm always going to get a negative number because you're always going to have a negative sign there. So this tells me that b sub n is always decreasing. Okay, so you want to make sure that you check that. I know sometimes it's obvious, but sometimes it's not going to be as obvious. You actually have to prove it. Okay, so then we check that. Okay, that one's decreasing. That's great. Okay, now all we have to do is now show that the limit as n goes to infinity of b sub n is equal to 0. So let's prove that. So the limit as n goes to infinity of 1 over n, okay, if I plug in infinity in there, you're going to have 1 over infinity, which gives me 0. So that is also true, okay? So what you say is, by alternating series test, okay, the sum from n goes from 1 to infinity of negative 1, what was it, n plus 1 over n converges. Okay, and we just proved that to ourselves. Okay, so there's two different things that you want to be able to do. Whoa. Okay, so there's two different things that you want to be able to do. You want to make sure that you show that it's decreasing and then that the limit is equal to 0. Okay, so now let's do another problem. Part B. So let's say you have the sum from n goes from 0 to infinity of negative 1 to the n minus 3 square root of n over n plus 4. Okay, so notice that this guy is also an alternating series because you have this negative 1 term in there to the power of n minus 3. So we have to use the alternating series test. So notice our b sub n is going to be this leftover part. Okay, so what we need to show is the same thing. We need to show that it's decreasing and also that the limit equals 0 as n goes to infinity. So first let's show that it's decreasing. So b sub n in this case is equal to square root of n over n plus 4. So what we're using is the alternating series test. I forgot to write that. Okay. So now we're going to write it as f of x. So f of x is equal to the square root of x divided by x plus 4. We're going to take the derivative, f prime, and you can use the quotient rule. And when I use the quotient rule, you're going to get 4 minus x over 2 square root of x plus 4 squared. So you can go ahead and show this to yourself. Everybody should be able to do the quotient rule by now. Or you can use the product rule. Okay. All right, and now what we're going to do, we're going to set it equal to 0, because remember, when we take the derivative, you can either get a critical point when it's equal to 0 or when the denominator is equal to 0. Okay, so we're going to set this equal to 0, so 4 minus x over 2 square root of x plus 4 squared equals 0. And you're also going to set the denominator equal to 0. 2 square root of x plus 4 squared is equal to 0. Okay, so if I multiply the denominator to the other side, we're just left with 4 minus x equals 0. Okay, so then x equals 4. Okay, so that's what we get for this one. This guy, we're going to set each of them equal to 0 to 2 square root of x equals 0. And then x plus 4 squared is equal to 0. For this guy, we're going to get x equals 0. This guy, we square rooted and move the 4 over. We're going to get x equals negative 4. Okay, so here are my critical points. Now you have to be very careful because notice that n starts at 0. Okay, so that means we can exclude this one because x cannot be negative, the n cannot be negative. So all we just have is x equals 0 and x equals negative 4. Okay, so what we're going to do, we're going to go ahead and check it out. Okay, so here's 0 and here's 4. Okay, we just need to make sure that this is decreasing. So eventually it has to decrease. Okay, so at n equals, between 0 and 4, how are we going to do this? Well, we had to plug in a point that's between 0 and 4. Okay, so one thing that you can plug in is 1. So let's plug in what happens when I plug in 1 to the derivative. So I'm going to plug in f prime of 1 into the derivative, into this guy. So we're going to have 4 minus 1 over 2 square root of 1, x plus 4 squared. Oh, I forgot to plug in the 1. Okay. And what you're going to get 3 over 50, okay, which is a positive number, okay? So because this is a positive number, from 0 to 4 is positive, which means that it's increasing from here to here, which is not good, because this is not what we want. But we want to make sure that as n gets relatively large, this is going to decrease. So let's go ahead and try it out. So now let's plug in a number that's greater than 4. So let's plug in 5. So we're going to have 5 minus 1. Oops, that's wrong. 4 minus 5 over 2 square root of 5 5 plus 4 squared. Notice that this top part is going to give me a negative number. The bottom part is just going to give me a positive number, which is going to give me a negative number. Okay, so this part is going to be negative, which means that it's going to be decreasing. So does that mean that I violated this? Well, not really, because in the beginning, from 0 to 4, you're going to have a little bit of an increase. However, as n gets relatively large, you're going to go ahead and see this decrease in the values. So is it okay if it increases a little bit? Yeah, it's okay if it increases a little bit, but eventually it has to be able to decrease. Okay? So we're going to say that b sub n decreases when n is greater than 4. So when n is greater than 4, that's when it's going to be decreasing. Okay? So now let's go. So we're going to say that this is going to be a decreasing function for now. Okay. So now what are we going to do? What we need to show is number 2. So 2. And we need to show that the limit as n goes to infinity of b sub n is equal to 0. Okay, so our b sub n in this case, the limit as n goes to infinity, okay, b sub n in this case is equal to square root of n over n plus 4. Okay, and now what we can do here is we can either use L'Hopital's rule if we really want to, or we can also use take the degree of the highest power. In this case, the highest power is going to be n. So we're going to divide everything by n. So limit as n goes to infinity, take the square root of n divided by n, then take n divided by n plus 4 over n. Okay. Okay, so now I'm going to have the limit as n goes to infinity. Okay, you're going to have n to the 1/2 over n divided by 1 plus 4 over n. So I have the limit as n goes to infinity. So this guy is just going to give me 1 over n to the 1/2 divided by 1 plus 4 over n. And now notice that this guy is going to go to 0. This guy's also going to go to 0. So all I'm left with is just a big fat 0 on the top, a 1 plus a 0. We have the limit part. And all we just have is a big fat 0, which actually is what we wanted. Okay, so because it's decreasing, and because it is equal to 0, by alternating series tests, the sum from n goes from 0 to infinity, negative 1, n minus 3, square root of n, divided by n plus 4, is convergent. Okay? So the toughest part about this problem is that testing whether this is going to be decreasing or not. So that's, I think, the hardest part. But doing some Calc 1 stuff, you should be able to figure it out. Sometimes it's going to be really easy to note, or the problem I say, assume that it's decreasing, so you just have to figure out the limit part.